Hi guys, my name is JJ Khoza. I am back again. We are now doing algebra. Up to now, we have done some couple of topics under the algebra. We started with the basics, the fundamentals of algebra. We have done real numbers. We have done properties of real numbers. We have done properties of negatives. And we have done properties of fractions. Now we are entering session number 4 of our algebra fundamentals, part 4. Here I am going to introduce something that is very interesting: algebraic expressions. In the algebraic expressions, you see a combination of everything that we've done so far. I've also forgotten to mention that we did exponents and radicals. We explained what exponents are, their laws governing the exponents, also the radicals. Why? All these things that I've mentioned, which we've done in our previous lectures, they count so much in algebra. You can imagine them as a foundation. You know, when you build a house, you have to have a foundation. You have to dig a foundation. You have to do a foundation. They are indeed a foundation. Even now, I am going to do expressions. Expressions are still a foundation of the algebra, because expressions, then you find them everywhere. You'll find them in functions, in graphs, you'll find them in geometry, you'll find them in trigonometry, you'll find them in financial maths, you'll find them in number patterns, you'll find them everywhere. Everywhere you go is all about algebra. So now, I want to explain algebra to you guys. I am talking about, let me write it in black. I'm talking about algebraic expressions. Algebraic expressions. I'm cleaning my board. Okay. So in algebraic expressions, we are going to talk about the building blocks of algebraic expression. That will enable you to understand an algebraic expression, because it is an expression. What is an expression? Think about it. You want to express yourself. So this is a mathematical way that we use to express our language in a mathematical format. We take a natural language that human beings speak, that we speak, and we express it in a mathematical format. Excuse me. So, when we do that, we need characters. In the natural language, well, if we speak English or, whatever language that you may speak, but for as long as it uses certain letters. So you may find that there's letters of alphabets, there's letters, different letters, because around the world people speak different languages and they use different methods of writing. Now, in mathematics, we also need that kind of a system which we can then use to construct our expressions. Right now I'm speaking English and I am using the letters of the alphabet. In algebraic expressions, I'm sure we're using 3, right? 1, is a variable. It's not writing well. A variable. Oops. A variable. A variable. Well, my E is too big now. Doesn't matter as long as you can read. A variable. What is a variable? Is nothing other than a sign or a symbol. It may also be a letter of the alphabet or a Greek alphabet, a Greek letter, whatever it is, whatever it can be, a sign or a symbol that represents an unknown quantity. It represents unknown quantity. Quantity. Yes, it represents unknown quantity. Okay? And We also use a constant. Constant. A constant is a freestanding number. Is a free standing number. Is a freestanding number. A freestanding number. And thirdly, this doesn't look like a 3. Come on. Okay. Thirdly, we use a coefficient. Efficient. A coefficient. A coefficient is a number that multiplies a variable. Is a number multiplying a variable. Doesn't look like what I want to write here. This should be an R. This should be an A. This should be an E. Come on. And this should be B. Yeah? Okay. Variable. This should be A. It must look round. Variable. Yeah. Now, on number 2 and number 3, we talk about a number. There is a question that I always like to ask. All those who know me personally, I'm sure they have came across this question. I always ask them, what is a number? This is very interesting. I find that many people, they finish their schooling life, they finish their degrees, and they work, and they've got vast experience. But interestingly so, you ask, what is a number? You know, no answer. You see a person scratching his head, starting to reconstruct the definition of a number. Well, I always like to ask that question. What is a number? I'm asking again. Do you want to answer? Send your answer. Alright. I'm going to give you a definition of a number. A number is a symbol that has been assigned to a specific known quantity. You see, it's almost similar to a variable. The difference is that this symbol has been assigned to a known quantity, whereas a variable is a symbol that represents an unknown quantity. That's the difference. Unknown and known. On the variable, unknown. On the number, it's known. So a number is a symbol that represents a known quantity. So if I write 1, 1, 2, 3. This does not look like a 3. What's happening? Well, this is bad. But whatever number it is, it does not have any meaning, It's meaningless. What is it that make numbers make sense? These symbols that we use. What is it? They are assigned to specific values, to a specific known quantity. Therefore, it makes sense. How do you tell a child? You look at grade 1. You are teaching a child to count. But to a child, the child can count 1 up to 10. It's meaningless to a child. Absolutely meaningless. Because 1, 2, 3, 4, 5, A, B, C, D, up to J. To a child, it's just the same thing. That is where we need to differentiate. You need to know the difference between a variable and a number. Okay. Let's move to the next slide. So algebra, after all, it does not have this much difficulty. In English, we're using all the letters of the alphabet, and they are how many? How many letters? 20? I can't hear you. Okay. There are more than 20 anyway. But in algebra, how many characters do we need to do algebra? 3. Now tell me, how can it be so difficult to express yourself in algebra when you are only using 3 characters? It can't be. And the variable, it's nice that it can take any value. Any value. So that is why in mathematics we don't need many letters of the alphabet. We simply use X and Y. That's it most of the time. And we can capture everything that we want to capture. At a certain time, at a certain instances, we also use T, right? When we're doing, for instance, Brownian motion, you'll introduce different variables. So it depends what you do. But you will never get to use like 20 characters. Okay, guys. Now, let us start the real business of the day. An algebraic expression is the way of expressing yourself using these three things. You are really expressing yourself. So, in expressing ourselves, if I say I have a thing, I can just write X. I have a thing. This is it, X. I have a thing and I increase them by 2. To increase is to add by 2. So I have a thing and I increase them by 2. I have 3 things. I have 3 things and I reduce them by 10. This is how we express ourselves in algebra. I think once you develop this language to a level of proficiency, you can listen to comedians and express their comedies in an algebraic format. We'll look at them and laugh because we understand the language. Okay. There are many things that you can do. I want to explain something important about algebraic expressions. We have 3 types of algebraic expressions. I want you to know them. The first one, so I'm going to write types. Types of algebraic expressions. My pen is not writing well. I don't know what's happening. Types of algebraic expressions. Types of algebraic expressions. Okay. All right. The types of algebraic expressions, there is 3 of them. If you notice, you'll see that I always list my work in order. Why am I doing so? I am organizing it and arranging it in order. So my filing is properly. And I always list them. You go back to all the lectures, you'll see my work is properly ordered. I expect your notes to be as such, to be properly ordered, so that you don't get confused. Okay. Right. Now, the first one, we have a monomial. a monomial. A monomial. What is a monomial? Is an expression which does not have any number operation between them. So if I write 5, just a 5, this is a monomial. I write 3x, this is a monomial. I write 8x squared, this is a monomial. I write negative 10 x y, this is a monomial. There is no number operation, there is no plus, minus, you just have either a coefficient with a variable or a constant. That's what you have. You may have two variables that multiply each other and even together with a coefficient. Still a monomial. And then you find a binomial. On the binomial, you have two terms. Most people think that a binomial has got anything to do with the power. For instance, people normally think of difference of two squares, Not really true, but a binomial you have two terms. You have two terms in a binomial. So a binomial, you may have something like 2 plus 3x or you may have 6x squared. Wow, I want to write 6x squared, not this. Should be square minus 5. You may also have ax plus b. This is a binomial. Are you clear? A binomial. Number 3, we have a trinomial. Again, this has nothing to do with an exponent to the third degree. People normally have that confusion. A trinomial. Tri means 3, bi means 2. It refers to the terms. Okay, a trinomial. A trinomial has got 3 terms. The famous one, I want to write x squared. X squared plus x plus 1. Well, you can have different types. You can have ax plus by plus cz. Okay. We have now discussed types of algebraic expressions. I now want to do something on the algebraic expressions. So far I've been explaining what algebraic expressions are. Is a way of expressing ourselves using a variable, a constant, and a coefficient. We now speak about algebraic expressions. We have a monomial, a binomial, and a trinomial. On the next lesson, part 5 of Algebra Fundamentals, because this is a series of lectures on algebra, I am going to talk about how to work with algebraic expressions, how to simplify them, in other words, how to manipulate them. We are going to do different types. We are going to use expressions where there is multiplication, where there is a distributive property. We are going to use where there is a need for factorization of algebraic expressions. Factorization, yes. And then it means you must know what is a factor, what a factor is. We are also going to talk about fractions. Fractional expressions. Our next lecture will cover those things, some of those things, so that you get the basics properly. My intention with these lectures is to enable everybody who has had a problem with algebra, with mathematics, to gain 100% knowledge, to gain confidence, and to be able to use mathematics, to understand mathematics. That is my intention. That is what I want to achieve. I want people to understand mathematics. Okay, guys. Please don't forget to like my video and give me thumbs up. Subscribe and send to anybody who likes mathematics Even your colleague, elderly people, sometimes you find that he wanted to learn mathematics. He never had a good opportunity to learn. This is the ultimate opportunity to learn mathematics. And guys, send to all